Hello, welcome back to Binary School. In this part of Binary School, we're going to have part 2 of our computer mathematics or arithmetic. One of the things we need to know or need to understand are the comparators, or comparison operators as they're often referred to. Let's have a little example. Well, previously we've encountered this symbol here, mod. Okay, 12 mod 9. That means 12 divided by 9 and return the remainder. Yep, 12 mod 9. Well, 9 into 12 goes once and 3 left over. Okay. But you might want to evaluate, to compare with a computer program. And so very often the algorithmic representation is an exclamation mark and the equals, which means not equals 2. So this is saying 12 mod 9 not equals 2. Okay, so have something to compare it to. 23 mod 10. Now, that's a Boolean operation, essentially. It will either be true or it will be false. It can't be maybe, it will be 1 or it will not be 1. Okay, so 12 mod 9, well 12 mod 9, we already agreed that's 3. 23 mod 10, well 23 divided by 10 is 2, with 3 left over. Okay, so they are equal to, so is it true or false that 12 mod 9 is not equal to 12 mod 3? Well, it's not true, is it? That they're not equal to, or is it false? It's actually false, isn't it? Yeah. So we think about it. Not equal to is false because they are equal to. Okay. Tricky one, that one sometimes. So, make sure that you're quite familiar with it. So let's carry on. Let's do another misconception really that people sometimes have. Let's have some variables. Let's have A, B, and C. Let's give A the value of 5, B the value of 10. Okay, and C, the value of B minus A. Okay, so those are all equal signs. They're assigning values. They're saying A is equal to 5, B is equal to 10, C is equal to B minus A, whatever B and A might be, because the variables, they could change, of course. Okay, so in the comparison that we want to engage in is notice that's a double equal sign. That is saying, is C equal to A? And again, it will either evaluate out as true or false. Okay, true or false. So I'm like, well, A is 5, B is 10, C equals B times minus A rather. Well, 10 minus 5 is 5. Is C equal to A? Yes, it is. So there we are. So that Boolean expression evaluates out into T, or true. Okay, so let's have a look at a couple more. Well, very often you will see this sign. Oh, it's a good idea to practice this one just to get it the right way around. Now, so let's take something that we've covered before. So 2 to the power of 4. And that means, is 2 to the power of 4 less than or equal to? Let's put a value in there. That's either going to be true or it's going to be false. So it's 2 to the power of 4 less than or equal to 16. Well, 2 to the power of 4 is 16. It's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So that would evaluate out as true. Okay, so let's try another one. 2 to the power of 4 again, but let's reverse it. Okay, so let's reverse it. 2 to the power of 4. Is it greater than or equal to 8? Well, we know 2 to the power of 4 is 16. So 16 is greater than, here we are, it's greater than 8. So again, that would evaluate out as true. So we've covered 4 comparison operators within programming, within computer science. The not equal to, the equal to, the less than or equal to, and the greater than or equal to. Really important that you understand how each of these works. They crop up in all sorts of ways. There might be an algorithm that asks you to convert the algorithm to a program, or it might be a context statement that asks you to create the algorithm using correct symbology. Yeah, get the idea. Okay, good luck out there.